Have you ever just looked around and noticed how much stuff is, well, changing all the time? From the food we cook to the plants growing outside, change is literally everywhere. But have you ever really stopped to think about what these changes are? Today, we're going to peel back the layers on all the different types of changes happening right under our noses. I mean, think about it. You see a little bud on a rose bush one day, and the next it's this beautiful, open flower. It's a natural transformation, right? We see it, we know it's a change, and we usually just move on. Okay, now think about a banana on your kitchen counter. It starts getting those brown spots, and then it develops that really strong, sweet smell. Now, that's also a change, but it feels different, doesn't it? It seems like something more is going on there than just a change in how it looks. And it just keeps going. A cold bottle of water you left out gets warm. The ice cubes in your glass melt. You chop up a carrot into little pieces for a salad. These things are so common, we barely even register them as changes. So, this leads us to the big question. A flower blooming, a banana going brown, an ice cube melting. Are these all the same kind of event? Or are we looking at totally different categories of change? Well, let's find out. All right, let's dive into our first category. These are the changes that are, basically on the surface. They alter how something looks or feels, but not what it fundamentally is. So here's the official scoop. A physical change is all about messing with properties like shape, size, or its state. Think solid, liquid, or gas. Water turning to ice or ice turning to steam. But here is the absolute key, the most important part. No new substance is actually formed. The stuff you started with is the same stuff you end with. Let's make this super simple. If you take a piece of paper and cut it into a bunch of tiny pieces, what do you have? You have tiny pieces of paper. The substance itself didn't change. Or if you inflate a balloon, it gets bigger, but it's still made of rubber. Crush a piece of chalk into dust? Yep, you guessed it, it's still chalk. The form changed, but the material is exactly the same. But then you have the other kind of change, the kind that goes way deeper than just appearances. These are the ones that create something brand new. And this, my friends, is a chemical change. This isn't just about shuffling the old material around, it's about a whole new creation. It happens through what we call a chemical reaction. You start with one set of ingredients, and you end up with something completely different. So, how can we actually prove a new substance was made? Well, check out this simple test. If you take a straw and blow into a glass of plain old water, all you get are bubbles. Kind of boring. But if you do the exact same thing with something called lime water, the carbon dioxide you breathe out actually reacts with it, and the clear liquid turns all cloudy and milky. That milkiness, that's a totally new substance called calcium carbonate. That milky cloudiness, that's the clue. It's the smoking gun. It's the visible proof that, yup, a chemical reaction just went down, and a new substance was born. You can't just undo it. It's a fundamental change. And believe me, this isn't just some neat lab trick. These deep, fundamental changes are happening all around us, all the time, in some pretty dramatic and honestly super important ways. So, here's a perfect side-by-side. Physical changes are all about form, and you can often reverse them, like freezing water into ice and then melting it back. But chemical changes? They create new stuff, and they're usually a one-way street. You can't unburn a log, right? We've all seen this, a rusty old gate or a nail left out in the rain. It's easy to think of it as just iron that's gone bad, but what you're actually seeing is a chemical story unfolding. See, rusting is a classic chemical change. The iron is reacting with oxygen in the air and with water, and together they create a totally new, flaky, reddish-brown substance, iron oxide. It is not iron anymore. It's rust. A whole new thing. Okay, let's dial up the drama a bit. When you burn a thin strip of magnesium, you get this incredibly intense, brilliant white light. I mean, wow! That amazing light is a dead giveaway that a really powerful chemical change is happening. That reaction has a name, combustion. It's basically what we call burning. Anytime something reacts with oxygen and gives off heat and light, that's combustion. It's a chemical change that transforms whatever was burning into ash, smoke, and pure energy. Okay, so you're feeling good, you know the two categories, but what happens when a single process seems to do both? Let's investigate the curious case of the burning candle. Think about it. When you watch a candle burn, you see the solid wax at the top melting into a liquid pool. But at the very same time, that flame is clearly consuming something. So what's really going on? Is it a physical change or a chemical one? And here's the big reveal. It's both. The wax melting from solid to liquid, that's a physical change, just a simple change of state. But the flame itself, that's causing a chemical change. It's heating up the liquid wax until it turns into a vapor. And it's that vapor that's actually burning, reacting with oxygen to create light, heat, and new stuff. How cool is that? 2 changes in one little candle. So now you've got the tools. You've got the new way of looking at the world. You're not just seeing things happen anymore, you're seeing the hidden processes behind them. So let's do a super quick recap. If it's still the same stuff, just in a different shape or form, that's a physical change. But if something totally new has been created, that's a chemical change. And remember to look for the clues. A new color, like rust, heat and light, like a fire, or a brand new substance appearing out of nowhere. All right, I'm going to leave you with a little puzzle to think about. What about milk? When it goes sour and curdles, it goes from a smooth liquid to these lumpy solids and a watery fluid. So based on everything we've talked about, what do you think that is? A physical change or a chemical one? Think about it, and you'll start seeing chemistry everywhere you look.